Hey y'all, here's a super short video on finding a quadratic function from just its roots. So, if you recall, one of the things that we talked about was that for quadratic functions, whenever I'm talking about finding something like a quadratic function's roots, or finding its zeros, or finding its solutions, or finding its x-intercepts, I'm actually talking about the same thing, and I'm referring to wherever a parabola crosses the x-axis, right? And most of this lesson has been focused on going that way, on having some quadratic formula, some quadratic function, let's say something like x squared minus 3x minus 18, and then finding its roots, and you going, okay, well, I can factor this, right? I don't factor somewhat like this, and then saying, oh, well, I know that the x-intercepts cross at the x-axis, therefore y is equal to 0, and so that's what you do. You plug in y is equal to 0. Y'all know that when you're multiplying two things together, and they're equaling 0, that at least one of them has to equal 0, so you're going to set this one equal to 0, or you're going to set this one equal to 0, and thus find the 2 points on the x-axis where the parabola crosses, right? Well, what if it didn't work that way? What if I instead, hint hint on your test, told you to actually work backwards? What if I told you, hey, I have some roots, a quadratic formula with some roots, let's say 7 and -9, and I told you, alright, now tell me what the actual quadratic function is, just me having told you those two x-intercepts. Well, what you're going to do is actually work backwards from what you usually do, and you're going to say, alright, rewind. If I had just factored these two, I would have had something like x minus 7, x plus 9. Notice how I switched the signs, right? Whenever you're coming in and out of parentheses, you switch the sign of your root. So, if these are your factors, that means that they came from some quadratic equation where I can just FOIL, right? Okay, so if I combine my like terms, that means that my original quadratic equation was this. Now notice that is not, this is an expression, so if I wanted to say what was the quadratic function to begin with, what was the original, notice how this guy actually had a y equals, right? So you're going to tell me that the function was just this. And that's how you work backwards. That's pretty much the meat of this video. Now, if you've thought about this long enough, and have been able to notice some discrepancies, more power to you. What does this assume if I tell you that this is the original function? Well, it assumes that to begin with, you really only had something that had not been stretched, right? Where the leading coefficient was 1, and something that was not flipped. The leading coefficient here is positive and not flipped. Right? It faces right side up. So more power to you if you realized the two big things that I'm kind of assuming here in order to find the original function. But that's it.